So chapter 7 is on the scope and sequence. It's supposed to be the last chapter we cover for marking period 2. So this first section is going to talk about triangle application theorems. So theorem 50 says it's the sum of the measures of the three angles of a triangle is 180. So all angles in a triangle add up to 180. An exterior angle we know is an angle, or angle 1 is an exterior angle. We know from prior lessons that an exterior angle is adjacent to and supplementary to an interior angle. So again, whatever the interior angle is, it needs to make a straight line. Adjacent means it's next to, and they need to total 180 degrees. Theorem 51 says that the measure of an exterior angle of a triangle is equal to the sum of the remote interior angles. So a few sections back, we had learned a theorem that said the exterior angle is greater than the measure of either remote interior angle. So the previous theorem had said that angle 1 was bigger than angle D, and angle 1 was bigger than angle E individually. But this new theorem is now saying that angle 1 is equal to the sum of angle D and angle E, which would allow you to come up with an algebraic equation. For theorem 52, that's our midline theorem. That has a name to it. That's the name that you would be able to use if you're ever trying to justify something. So it says a segment joining the midpoints of two sides of a triangle is parallel to the third side, and its length is half the length of the third side. So if you have a segment joining the midpoints, so if H is a midpoint, and if M is a midpoint, then that segment HM is going to be parallel to JK. So they will be parallel to each other. And HM is going to be half the length of whatever JK would be equal to. All right, so first example here. So it says, given the diagram it's marked, we're going to find X, Y, and Z. So this is where you're going to use your knowledge of triangles, adding up to 180. So if we take the triangle, say, it doesn't matter which way, but let's say we take this one right here. Well, there's three angles in there, 55, 80, and Y. X and Z are not part of those. Those are not the angles in the triangle, and they add up to 180, and we get Y to be equal to 45. If we take the triangle on the right-hand side, and if we add up those angles, we have X plus 100 plus 60 equals 180, and X is 20. Then the inside triangle there is made up of X, Y, and Z, right here. So X, which we know, is 20, Y, which we know is 45, and Z, which we don't know, is equal to 180, and we solve and we get Z to be equal to 115. So example 2, it says the measure of the three angles of a triangle are in a ratio of 3 to 4 to 5. Find the measure of the largest angle. So ratio, we know we always add X's to our ratio values because it's a reduced ratio. And if we're talking about the three angles of a triangle, well, we know that that equals 180. So what we're going to do is we're going to take our 3x, 4x, and 5x and set it equal to 180, and we get x to be 15. But the question is asking us to find the measure of the largest angle. Well, the largest angle would be our 5x. So we're going to take that x of 15, sub that in.